Keren, thank you, Sarah. That was fantastic. And we'll have a good discussion about all this. Keren, if you'd talk about your technology.
Yes, thank you, Pam. And good morning and good evening, everyone. And best regards from Israel. Yeah, as you presented me already, Pam, I have a business background, and I bring my experience in the B2B business, high-tech global companies into the to introduce this new technology into the market that I will talk about. This novel technology that I will talk about was developed at the Hebrew University in Israel by two professors. One is expert in plant stress physiology, and the other is in soil and water science. And they both cooperated because they had problems in their own research. They couldn't really have an efficient way of doing their research. They had to experience and research plant by plant, not in a very efficient way, and also not precise. And when they had a certain digital device, always it was on a part of the plant, not on the whole plant. So they wanted they came up with an idea how to improve that. And they actually used this technology already for more than 10 years, as it started as a prototype. And after we started to commercialize it, of course. So this is kind of the background also for myself, but mainly how the product was invented. And now I will talk more about the product itself. So if you can switch to the next slide, I have a problem too. Thank you. So when we're talking about phenotyping, and this is our field of expertise, we talk about one of the major issues is really the phenotyping bottleneck is caused by four major challenges. So this is in the R&D process, and today, one of the major challenges is that it takes a long time. And it takes minimum 2 to 4 years to come up with all the different stages in the development of discovery and optimization and formulation. And this prevents, of course, from fast new product introduction into the market. So this prevents us to go to market fast, all the bio companies. And with this product, we will try to address that, of course. So the long processes, this is one major challenge. The second major challenge is that most of the companies still use manual processes. If we talk about controlling and measurements of the plant, and the different treatments to be applied, everything is still mostly done manually. Of course, this brings a lot of errors into this process. Also, the assessment is more subjective. And of course, this also brings mixed results that at the end, it's confusing and hard to get into, very clear-cut results, go, no go. So, and the third challenge is that the plants are having plasticity versus the changing environment. They change over time, they change during the day, they change their response to the climate, they change between days, they change in different conditions, they change in different growth stages. And of course, we need a certain method to measure the plants in very high resolution in order to address that. The fourth element is the quantification of information. So also here, we need very high tools with high capabilities to translate the plant response into quantified data. And especially now when the regulations are upcoming, so to quantify the nutrient use efficiency, as well as the plant response to different stresses, this will be even more required. Next slide, please. Thank you. So what we invented is the PlantArray system, it's called. This is a fully automated phenotyping system. It is fully automating three major functions. The control of the different treatments in the experiments. I didn't mention, I will mention now, this is for performing indoor experiments, okay? Indoor experiments in order to screen plants and phenotype. So we're talking about three functions. The controlling of the plants, the measurement of the plants, and the analysis. All of this is being done automatically, but also on the same time on the system. So in terms of the control, we are controlling automatically the soil and water conditions. It is also a feedback system. So when you set up the experiment, you set up certain conditions, it maintains throughout all the experiment, even when the plants are growing. The measurements that we are doing is physiological measurements. Physiological measurements to do to the whole plant digitally. This is an innovative product that the only product that actually does have this capability to measure directly the physiological status of the plants, and we measure it all at once to all the plants almost 500 times a day. So the resolution is very, very high. And you can understand from that every change in the plant, every response we can capture. We also measure the environment at the same time that we measure the physiological status of the plants. So we can learn about the plant environment interaction. And the third function is the analysis. We're doing the analysis in real time. So all these 500 times that we're measuring the plants during the day is being uploaded, and even during the day, you can already see the results analyzed, not just showing you the numbers, but really analyzed with meaning, with statistical analysis. So you can take decisions during the experiment even, and change even some of the conditions or take whatever decisions you want. So the whole purpose of the system is to save time. So in one season, you can make a lot of different rounds, because every experiment takes between days to a few weeks. You get a very clear physiological profile of the plant and of your materials and how they impact the plant. So controlling, measuring, and analyzing the plants are being performed continuously and simultaneously to all the plants in real time and hands-free. Thank you. Next slide, please. This is a more detailed drawing of the process. You can see on the left is the personalized treatment for each of the plants. On the right are all the measurements that we take to all the plants at once. So you can see in black all the physiological parameters. We're actually measuring the root and the shoot together on the same time. Again, 500 times a day, the root and the shoot, and sometimes you see different behavior between the root and the shoots, a certain delay in performance and other phenomena. And so we measure root influx, root water influx. This is the water activity, the plant water activity from the roots. Then transpiration, stomatal conductance, water use efficiency, biomass gain. And all of that is, of course, a great indicators for nutrient use efficiency by the plants, because we control the nutrients application. So we know exactly how much nutrients we apply to each of the plants, and you can then, based on this parameter, understand how efficient is the plant with these resources. Then we also measure the environment at the same time. So you can see here in this slide many different sensors that we're using in the system, that you can measure the atmosphere, the soil, the solution, and all of that is being, again, 500 times a day simultaneously to all the plants, understanding the plant environment interaction. And all this goes into the cloud software, which then you can analyze from everywhere, from your desk at home, from your laptop, and you can have a very clear-cut results, analytical in terms of statistics for all the plants in the array. Next slide, please. This is an example of really the PlantArray system in action. If you can activate the video, it will be helpful. Thank you. So you can see here the plants growing, the data is gathered and presented at the same time. You can see a drought treatment here and also the recovery, and the different parameters are displayed graphically in different ways. Next slide, please. And here you can see an example of the statistical analysis. So you can see here a case study done with ICL materials, where you can see two different biostimulants, and the statistical analysis, ANOVA and t-test for drought and well irrigated, for these two biostimulants material against a certain fertilizer. This is a 1-month trial, and it was very clear from the beginning what the results are. And also throughout the process, ICL learned a lot about their materials, things they didn't know before, how they behave. They found out with this analysis, because sometimes materials also behave differently in the drought stage and in the recovery stage. And this is also part of getting mixed results in the field, usually when you don't know this upfront. And you don't know what to expect. In our system, you can actually know what to expect. And when you go to a field trial, you go to a much better focused field trial, you know how to direct it, etc. So just to summarize a little bit about the company. So the company is commercial since 2017. We already have customers around the globe from different disciplines. You can see here some examples. You can see in the biostimulants and chemicals, universities, food industry, and recently also we have CRO customers joining. So I advise, and I will love if you will go to our website to learn more about us, if you find this interesting. And also you can write me in the chat. I'll be happy to answer questions and get in touch personally. And I will also say that as a final point that at 12 p.m. today, I will be at our booth in a video chat. If you want to meet me and for Q&A and discussion, I'll be waiting for you. It's in the Pathfinder Expo Hall, so please look up for Plant-DiTech. Thank you for your attention, and success to everybody, all the companies here in the audience.
Thank you, Keren.